Ladies and gentlemen, thank you very much. I am Idewa Madicipta Santosa from Polytechnic Negeri Bali. Would like present our article with title Analysis Key Performance of Refrigerator Prototype with Photovoltaic. Introduction. In recent years, new concepts of refrigerators are developed according to eco-friendly concept. Eco-friendly concepts mean that refrigerator should be used natural refrigerant as well as renewable energy source. Indonesia has abundant solar energy, and this energy is one of the reasonable clean energy to be applied in our country. Therefore, to improve refrigeration performance, several optimization strategies are recommended. Previously, studies show that the DC or direct current refrigerator system, which is directly supplied with energy from photovoltaic, is more efficient and simpler than conventional system. The conventional system in this study is AC refrigerator, alternating current refrigerator, with energy source from photovoltaic with an inverter. Research method. Please have a look the schematic diagram of our experimental setup. The first system is PV array. PV array using SCG and then AQ. The system can produce two kinds of current, which is DC current load and AC current load with inverter. In this study, because the first step of our experimental, we only use AC refrigerator system. Our test rigs is this is solar panel completed by control system and inverter, and then our refrigerator, this is AC refrigerator, alternating current refrigerator, completed by humidifier and also instrumentation and measurements. Data acquisition and analysis. Temperature probe using K-type thermocouple, pressure transducer with voltage signal. Environment condition was measured using a specific logger which covering air temperature, humidity, and dew point. Data are logged at every 2 seconds. The thermocouples has accuracy plus minus 0.5 K, humidity plus minus 0.5%, and pressures 0.08%. The refrigerator prototype was designed to complete the medium temperature condition, which was set at temperature storage until 0 degrees C, and humidity was controlled at 80%. All system is running at peak solar intensity. It's around 11 AM until 3 PM clock. Login data at every 10 seconds and save in on the laptop. All experiment data is imported into a spreadsheet for easier calculation and analysis using simple statistic method. Data is tabulated in table as well as in graph. The calculation of performance coefficient or COP of the system uses a computer program. It's called COOLPAC. Results and discussion. Depend on data condition. It can be seen that the compressor works very optimally, so that data is taken while working only and data is not shown as whole. This is average data. Furthermore, the design of a better cooling room will be optimized, especially with higher insulation, so that the compressor load will be reduced to obtain more comprehensive data. Performance data in the condition mentioned above are obtained based on calculation of the coefficient of performance or COP from the results of calculation with and without load. The theoretical COP and actual COP value are obtained as follows. With load COP 3.32, actual COP 3.29. Theoretical with load COP is 3.26 and actual COP 3.23. The result of this COP, it can be seen that the system performance is quite good at 5 degree C operating temperature condition, and solar energy is fulfilled either directly or by means of batteries. This is our graph. So the temperature trend in each point from point 1 till point 6. This is the temperature state in refrigeration system without load and room work temperature setting at 5 degrees C. And the second graph is a temperature trend in our refrigeration test rigs from point 1 to point 6. This is performance with load and room work temperature setting at 5 degrees C. The conclusions, according to this preliminary results obtained, that the refrigerator prototype has worked well and the solar power supply can work continuously. The main indicator of performance, namely in terms of the actual COP obtained, is in average of 3.2. It can be concluded that the refrigerator system already has a good COP. However, because this result was still preliminary results, the equipment will be developed with more comprehensive testing conditions. By expanding the operating temperature rings, improving the control system with an analog digital system, and deploying system automation to achieve a higher COP. Thank you very much for your kind attention.